The 2018 Fuego volcano eruption in Guatemala, the 2011 Japan tsunami, and the 2023 Turkey and Syria earthquake all stem from the fact that the ground beneath us is constantly shifting. Hello and welcome to Z. Please don't forget to subscribe and hit the bell icon. Today, we reside on the fragmented remains of a supercontinent that began breaking apart 200 million years ago. Each year, the world map will continue to evolve until all land masses eventually merge into a single continent once more, with natural disasters underscoring the inevitability of this process. So, will we survive Pangea 2.0? Observe the world map. Don't the continents resemble puzzle pieces? It wasn't until the early 20th century that German meteorologist Alfred Wegener noticed South America and Africa appeared to fit together. He discovered patterns in minerals, plant fossils, and ancient animal remains across different parts of the Earth. For instance, coal deposits in Pennsylvania are the same age as those in Poland, Great Britain, and Germany. The Lystrosaurus fossil was found in Antarctica, India, and South Africa. How is this possible? Wegener concluded that the planet once had a single massive supercontinent, which he named Pangea, meaning the whole Earth in Greek. He presented his hypothesis in 1912, initially facing ridicule. However, subsequent scientific discoveries confirmed the Pangea hypothesis and the theory of plate tectonics. Evidence of its existence includes rounded granules found in the South African craton, formed by high-temperature impacts. Similar granules of the same age were found in Western Australia, suggesting these regions were once part of a single continent called Volbara. Over time, Volbara formed the second supercontinent, UR. About 1 billion years ago, UR merged with Nina and Atlantica, creating the supercontinent Rodinia. Rodinia later disintegrated, forming Pannotia around 600 million years ago, which also broke up and eventually became Pangea, surrounded by the ocean Panthalassa. Conditions on Pangea were favorable for diverse life forms. Tropical rainforests similar to the Amazon existed in its equatorial region, transitioning to vast fern prairies in drier areas. Unique animals thrived, like Tanystropheus, a long-necked reptile that fished with its neck, and Lystrosaurus, a tusked, shovel lizard that dug up roots. Drepanosaurus, a half-meter-long reptile with bird-like features and large claws, tore open bark for insects. Had these animals survived, they would dominate their modern relatives. But around 252 million years ago, a massive meteorite impact caused the worst mass extinction in history, wiping out 96% of marine species and 70% of terrestrial ones, highlighting the vulnerability of life on a supercontinent. The same fate could await humanity. In 1974, Canadian geophysicist John Tuzo Wilson identified a cyclical pattern of lithospheric plate movements, predicting supercontinents form every 200 to 600 million years. Eventually, the continents will merge again. American geologist Christopher Scotese predicts Africa will collide with Europe, forming mountain ranges like the Alps and Pyrenees, while Australia migrates north to merge with Southeast Asia. Scientists foresee a supercontinent named Pangea Ultima or Amasia, where all land masses unite around the equator. Coastal areas would resemble Brazilian beaches, but the interior would be arid and inhospitable, cut off from oceanic moisture. Illustrator Massimo Petrangeli's vision of Pangea 2.0 depicts extremely hot central regions due to dried-up rivers. Coastal property prices would skyrocket as strong winds, typhoons, and tsunamis become common. Deserts would dominate northern Africa and the western USA. Australia would border Antarctica, with tropical forests forming between cold and warm zones, fostering new species of primates and birds. The average inhabitant of Pangea 2.0 would likely have dark skin, hair, and eyes, living near the equator. A single language might emerge, fostering global citizenship with shared traditions and ideals. However, such close proximity could also lead to more frequent and affordable wars, rapid pandemic spread, and heightened vulnerability to large meteorite impacts, potentially causing another mass extinction. Throughout Earth's long history, it has witnessed cycles of creation and destruction, marked by cataclysmic events that have periodically reshaped the planet's surface and life. One intriguing hypothesis that has gained traction in scientific circles is the idea of a roughly 200 million year cycle of massive geological and biological upheaval. This raises the compelling question: is such a cataclysm happening now, or could it be imminent? Understanding the 200 million year cycle. The hypothesis of a 200 million year cycle of cataclysms is rooted in geological and paleontological evidence. Studies have indicated that mass extinctions, significant volcanic activity, and drastic climatic changes appear to occur in a cyclic pattern. One of the most well-known examples is the Permian-Triassic extinction event, which occurred approximately 250 million years ago and wiped out an estimated 90% of marine species and 70% of terrestrial species. Another example is the Triassic-Jurassic extinction event, around 200 million years ago, which paved the way for the dominance of dinosaurs. These cycles are believed to be influenced by a combination of factors, including tectonic activity, volcanic eruptions, and even extraterrestrial impacts. The periodicity of these events suggests that Earth's geological and biological systems may be subject to underlying rhythmic processes, possibly linked to the dynamics of our planet's interior and its interactions with extraterrestrial bodies like asteroids and comets. Geological indicators. Are we due for another cataclysm? To determine if we are on the brink of another cataclysm, scientists examine current geological indicators. One critical factor is tectonic activity. The Earth's lithosphere is divided into several plates that float on the semi-fluid asthenosphere below. The movement of these plates can lead to volcanic eruptions, earthquakes, and the formation of mountain ranges. Recent studies have shown an increase in volcanic activity in certain regions, which could be a precursor to more significant geological upheaval. Another crucial indicator is the Earth's magnetic field, which has exhibited unusual behavior in recent decades. The magnetic field protects the planet from harmful solar radiation, and its weakening could have dire consequences for life on Earth. Some scientists believe that changes in the magnetic field might be linked to processes occurring deep within the Earth's core, potentially signaling an upcoming period of heightened tectonic and volcanic activity. Biological indicators, a prelude to extinction? In addition to geological signs, biological indicators also provide clues about potential future cataclysms. The current rate of species extinction is alarmingly high, leading many scientists to believe that we are in the midst of a sixth mass extinction. This accelerated loss of biodiversity is primarily driven by human activities such as deforestation, pollution, and climate change. However, it could also be seen as part of a larger, natural cycle of extinction events that have punctuated Earth's history. The fossil record reveals that past mass extinctions have often been preceded by significant environmental changes, such as rapid shifts in climate and ocean chemistry. Today, we are witnessing similar changes, including global warming, ocean acidification, and widespread habitat destruction. These trends suggest that we might be approaching a tipping point that could trigger a cascade of ecological collapses akin to those observed in previous mass extinction events. Human influence, accelerating the inevitable? While natural processes undoubtedly play a significant role in Earth's cyclical cataclysms, human activities are accelerating many of these processes. The unprecedented scale of industrialization, urbanization, and resource extraction has profoundly impacted the planet's ecosystems and climate. The Anthropocene, a proposed geological epoch characterized by significant human influence on the Earth system, underscores the magnitude of our impact. Human-induced climate change, in particular, is a critical factor that could exacerbate natural cycles of upheaval. Rising global temperatures, melting ice caps, and more frequent extreme weather events are already causing significant disruptions to natural systems. These changes not only threaten human societies, but also increase the likelihood of triggering larger-scale geological and biological processes that could lead to a cataclysm. Conclusion: preparing for the future. While the evidence suggests that Earth may indeed be on the cusp of another cataclysmic event, predicting the exact timing and nature of such an event remains challenging. The complex interplay of geological, biological, and human factors makes it difficult to pinpoint when or how a cataclysm might occur. However, the signs are clear that significant changes are underway, and it is imperative that we take proactive measures to mitigate their impacts. Understanding Earth's cyclical nature and our role in accelerating these cycles is crucial for developing strategies to protect both our planet and ourselves. This includes reducing greenhouse gas emissions, preserving biodiversity, and enhancing our resilience to natural disasters. By acknowledging the potential for a cataclysm and taking steps to address it, we can better prepare for the challenges ahead and ensure a more sustainable future for all life on Earth. Would you risk living on such a supercontinent? Share your thoughts in the comments and pick a country you'd consider moving to on this new map. Thank you for watching and see you next time.